for the networking part of the event. Thank you very, very much. So next up is Steve from Splunk.
Good evening, everyone. Is this on? How many of you have heard of Splunk? Where's the clicker? Excellent, excellent. So I don't have to talk too much about what Splunk does. But first, the obligatory comparison over time of search results. This is comparing big data to Barack Obama over the last year. And, a year ago, big data and Barack Obama were roughly the same popularity. And despite it being a presidential election year, big data is growing in popularity, and Barack Obama is staying at roughly the same popularity. Big data is very important right now. And looking at massive amounts of data is very important. And one of our customers is actually the Barack Obama campaign through the startup Optimizely. How many of you have heard of Optimizely? So for those of you who haven't, they allow people to do A/B testing in the cloud. So attach their JavaScript bug to your web page, go to their interface, and you can tweak a web page, and it changes for 10% of the viewers of the page. They're using Splunk to figure out exactly the effects of those changes. So this should be old news to most of you. This small bar at the bottom, the small area at the bottom represents traditional relational data. Over time, it's grown at an accelerating rate, not really a stunning rate. And sometime around the third dot in the x-axis, people started collecting additional data. And usually this additional data is from machines talking to other machines. So how many of you in this room have an iPhone or a BlackBerry or an Android device? That device is constantly talking to your email server. If you have a recent version of iOS, it's probably talking to Twitter's API server. And every time your device talks to one of these machines, a little bit of data gets logged. And this new data, this unstructured data, machine-generated data, contributes to this massive explosion of data over the last, say, 5-10 years. And Splunk's job is to make that data accessible to you. So here's our obligatory marketing slide. Sorry about it, but what does Splunk do? Splunk collects all of this machine-generated data. We have a product that's easy to deploy. You can bring this data in quickly and get value quickly, and we'll see that in a demo. So some examples of this large amount of data. Certainly networks generate data. Databases generate data about their operation, applications, the cloud, your operating systems. Data is coming into the system everywhere. And one of the important things about Splunk is that we found that in systems that require that you understand the data up front, people just don't deploy those systems. They're just too hard to get working. So with Splunk, you don't have an upfront schema. It's very similar to Hadoop in that way. You bring the data in, and then you run the analyses when you want to. So to reiterate this point, if you were going to talk about taking all of the data from your web servers and put them in a relational database to do traditional web analytics, you'd probably start by looking at your web access logs. And you decide, I need a column that represents client IP. I need a column that represents the timestamp. I need a column that represents the HTTP method. I need a column that represents the URI, and the number of bytes transferred, and the status code, and the refer. And you'd think that you were done. And then you'd realize sometime, maybe a couple days down the line, a couple weeks down the line, that a lot of the value in the URLs in web access logs come from that funny thing after the question mark, all of the query string arguments. And then you think, how am I going to fit this into my traditional relational database? And unfortunately, your application developers decide, oh, I'm going to create a brand new key value pair that goes in the URL that means something that's tremendously important. So with Splunk, we do all of this at retrieval time. So we do as little to the data as possible when it comes into the system. And when you search, we extract all of the value. And we scale. So we can collect data from thousands of orders. So as an example, we have a large social gaming company that has one of our little pieces of software, the agent, running on every one of their application servers that's serving up your favorite games, Farmville, Mafia Wars, whatever. That data is forwarded to a cluster of tens, hundreds of servers that allow people to search. And now let's actually head into the demo to see what we can do using a fun data source. So in this Splunk instance, I have a feed of Twitter. I stood this up yesterday, the day before. It's running in EC2 on a single server. And we have the Twitter Spritzer feed. Does everyone know what the Twitter Spritzer feed is? No. Nobody knows. So the next talk is going to be from GNIP. And they sell the Twitter Deca hose and the Twitter half hose, which are much larger feeds than this. I should have actually demoed with that data since we have it running in this Splunk system. But Twitter provides a real-time streaming API that has, what is it, about 1% of all tweets. So this is this data flowing into Splunk. Just to show that it's live, we can search in Splunk for Matt Turck. Missing a T.
TK.
And unfortunately, since this is only a 1% sampling of feeds over the last day, I only have 2 tweets about Matt Turck.
How about Kim Kardashian?
Let's do that. Kardashian. So let's actually see Jeremy Lin.
You're not a true fan, you'd be there.
And so now we see this trend of data of tweets that contain Jeremy Lin. We didn't have to think about analyzing this data to get this. We just have this plain old text feed of tweets that we render nicely because they're JSON. This is actually what it looks like when it comes from the Twitter folks. So let's go back to the pretty version. And the whole basis of analyzing data in Splunk is search. So we started as a company that was aimed at helping IT people solve their IT problems with that massive amount of IT data. Answering those problems by putting a Google-like interface on large amounts of machine-generated data. Because we're kind of Unix people, I hope I'm not offending any Windows people in the audience, but the way that we extended the system to allow you to process the data is through a pipeline model. So imagine at the far left-hand side of the search string, you have a tremendous amount of data that's unstructured, and you filter it by typing in these keywords and these field equals value pairs. If you want to process it, we have a command called spath that can go through the JSON feed and extract interesting things. So what hashtags seem to co-occur with Jeremy Lin? Oh, Linsanity, Knicks, Linsanity, NBA, Knicks, NYK, Lin. I don't know what this confession night is. This is Twitter, and this is live data, so let's just not ask. We can take this and analyze it pretty easily. Top values by time. And so most of the tweets don't have any hashtags associated with them. Several have others. Let's actually take out Jeremy Lin and just see what the trend of hashtags over time is. Last 15 minutes. Let's actually turn off null and other. Oops. Let's go back to our chart. Make it a little bit bigger. And one of the points that Hillary made was that it's often hard to analyze real-time data in systems. And so in Splunk, we make it very easy to analyze real-time data. So if you want to run the search, instead of over this historical last 15 minutes, you can say, let's run it over a real-time data feed, marches back in time, fills a time window, and it keeps on updating as time goes on. So we can see a dashboard of that in action. Top Twitter statistics. So you can see this moving over. So it's fairly easy to take all of these individual reports and build a sophisticated dashboard that shows exactly what's going on. Looks like Justin Bieber was most mentioned in this hour. And one of our customers, NPR, said that one of their favorite parts about Splunk is that since we take in all of the original data and store all of the original data, no data is harmed in making reports. It's a very important point, because when you think about how you're going to analyze large amounts of data, you don't want to take that data and irreparably condense it to a small amount of data. You want the source data there if you decide that you want to ask a brand new question. So that concludes my Splunk demo, and I think that we have time for a couple of questions.
Yeah, absolutely. Actually, since we didn't have a lot of time to ask questions in the print, let me skip my questions and turn it directly to the to people here. If there are questions.
How much does it cost?
You can ask our sales guys. They're here. But the short answer is that if you're bringing in less than 500 megabytes of data a day, it's free. So you can go to Splunk.com, download the product, use it in perpetuity at less than 500 megabytes of data a day, which is, in and of itself, a good amount of data. If you have more data than that, then you can talk to the sales team. I'm not the right person to talk to. I'm the VP of engineering.
Okay, so I have a question in the meantime. So I'm interested in your cloud strategy. So there is a new product coming out, and so what is it, and how much demand do you see it for it?
We see a lot of demand. So our cloud product offering is called Splunk Storm. It was the beta offering was announced last August, and it's going to be available in the next couple of months. And it's fairly important for a couple of reasons. It's important for people who want to stand up a Splunk instance very quickly if they don't have hardware. So if you look at how software companies are being run now, a lot of developers don't want to have to deal with procuring hardware, installing standard pieces of software on their system. And so the first step of that is environments like Amazon EC2, where you can have virtualized hardware, bring it up, install all of your normal applications on. The next step seems to have been that developers don't even want to have to stand up a database on their own. They'll provision a database in a database service use the database, something like Amazon's RDB or other services, and have a database ready. The same thing is true for enterprise management functionality like Splunk, where developers want the ability to dig into log files, dig into their metrics that they record, but they don't want to have to worry about managing a machine. So they'll stand up an instance in Splunk Storm, start sending data to it, and start analyzing it. Okay. I could have demoed that. I have some my wireless access point at home is feeding all of its data into my Splunk Storm instance.
So another thing I find amazing about Splunk is that simplicity seems to have been a core principle in the design of it, and there seems to be a trend in how modern enterprise products are designed, whether that's Box.net or others, towards really very much bringing the simplicity of the consumer internet experience into enterprise. How did you guys think about that?
Well, when the company was started, so I've been at the company now for 7 years, and the goal was to make software that we ourselves would want to use. We had used a lot of enterprise software, which was very unpleasant to use, and we took lessons from that, and we took lessons especially from consumer-facing software like Google. How would Google solve a problem like this? And so we built that type of simplicity into the software.
How much of your business is still traditional IT, and how much is being used for other kinds of data?
Over time, other types of data is certainly growing. Certainly, our dominant market is still traditional IT for traditional IT use cases like security and operations and management. But over time, it's certainly grown a lot, and people are using Splunk for fairly non-traditional use cases. Certainly, the more interesting ones are about analytics. So instead of bringing the data into a home-built system to analyze it, they'll bring non-traditional data into Splunk, like tweets, to look at it.
Okay. We have time for one more.
I'll just look at the website.
Can you do anything, operations on data that is not generated by a machine, like email contents, for example?
So basically,
you want to repeat the question?
Yeah, the question was, can we operate on data that isn't generated by a machine, like image contents? So it's a good...
Or email contents.
Or email contents. So email is relatively easy to handle. So we really require two things of the data before it's processable by Splunk. Number one, it has to have a timestamp. So time is a first-class concept in our system. That's how we organize data from beginning to end. And second, it has to be able to be turned into text. It doesn't have to be English. It doesn't have to be ASCII. It can be any Unicode text, but it has to be text. And for our index to work effectively, we have to have well-defined parts of text that we can absorb and perform keyword indexing on. So yes, emails are not uncommon. Our CTO likes to use Splunk to read his email, but he's a little bit strange that way.
You telling me it's strange?
Yeah, but yes, he'll agree. I've tried to read my email with Splunk. It wasn't as satisfying as an experience. He made it out to be.
What do you normally use?
I think that he uses Outlook Web Access, so I think that Splunk is a step up from that.
Okay, great. Well, thank you very much.
Thank you, Matt.
So again, Steve will be around after.